it's another chemical equation that has a delta H associated with it. This is example 8.5 if you're using our textbook. So we have coefficients in this equation. We've got a 2 in front of the hydrogen, we've got a 1 in front of the oxygen, and a 2 in front of the water, and that's liquid water. So they're saying, hey, if you take gaseous hydrogen and you burn it, you'll end up with water, and when you end up with water, you get a release of energy of a release of 571.6 kilojoules of energy per 2 moles of hydrogen that you burn, per 1 mole of oxygen that is combined, and per 2 moles of liquid water that are produced. So that number is tied to all these. Now they're asking you in example 8.5 to calculate the delta H for this equation. So in this one we have water not as a product, the water is a reactant. Okay, so when you are asked to do something like this, you have to look at what equations you're given and think, what mathematically am I going to have to do, or what am I going to have to do with this equation to turn it into something that looks like this? And the first thing that we should recognize is that the product is going to become the reactant. So if I just take this equation and rewrite it as 2 okay, all I did was reverse it. We would have a delta H of 571.6 kilojoules. So that's the amount of energy we're going to need to put in to take this water as a liquid and turn it into 2 hydrogen molecules and 1 oxygen molecule. Right? So when you see this delta H, right, it's kind of a difference in the enthalpy. Sometimes if you shorten, you think heat content. Difference in the amount of energy of the reactants and the products. So in this case, in the top case, the reactants have more energy than the products, because as we form the products, energy is released. And then when we reverse it, we need to put energy in to get to these products. So in this case, the reactants have less energy than the products. Right? This one is endothermic. This one is exothermic. So we still didn't get to the equation that they want, but we did get H2O as a reactant, which is what they give you. But now what we need to do is to get the coefficients to match. Okay, and so if we multiply this equation by 1/2, right, times 1/2, we get 1. Times 1/2, we get 1. Times 1/2, we get 1. Well, then that means we're going to need to take this and multiply it by 1/2. And so what do you get? 285.8. Okay, so whatever you do to those coefficients, do the same thing to delta H.